This is the second part of the tutorial, and it is dealing with turning this flat that we drew in the last tutorial into 3D. The important thing in this step is this navigation palette over here. At the moment, the class options are show, snap, and modify others. So pause here for a second. The little tick here is the active class. So if I've got show, snap, modify others, even though I'm on the active sheet class, I can still click on the plates. If that makes sense, I can still click on the frame, even though the sheet is the active class. If I change that to show, snap, others, then I can, if I go back to the plates class again, I can't click on anything except plates. That makes it a really powerful tool. So make sure you have your class option set to show, snap, others for this next bit. Okay, the first thing we're going to do is select the frame and we're going to make it 3D. So because I'm on show, snap, others and only the frame I'll only be able to select the frame objects. I don't know why I'm having such trouble with that this evening. If I just draw a big box around there, I only have the 5 frame objects. I didn't need to go around and click them individually. Only the frame objects were able to be selected because of this tick. Okay, then I'm going to go to Model, Extrude, and I'm going to extrude the frame by 25 millimeters. That's that done. Then I'm going to go to the plates. Again, put a little tick down there. Click anywhere to deselect everything, then draw a big box around there, and only the 4 plates are selected. I'll go to Model, Extrude, and extrude those by 6 millimeters. Again, click somewhere else, and if the colors are going from your drawing, then that's a good thing. And the last one is the sheet there, which again, if I click on there, as long as I've got only select the things in that class, then just draw around it, and I've only got one rectangle, which I'm going to model, extrude 4 millimeters. Okay, so that's the converting to 3D done. I'll just do a little spin around that just now, and it is a 3D object. I haven't done that very well, it's better doing the, just to let you see how I've done, but everything is inside each other. The plates are sitting on the floor, the frame's sitting on the floor, and the sheet's sitting on the floor, so not particularly useful. Go back to top plan again. I need to have a little think about what I'm doing here. So I know that the sheet as we're building it, if you understand how theatrical flats are made, this is lying on the workshop floor and we're looking down on it. The bottommost object is the sheet, which has, now that it's a 3D object, it has a Z value. Z is the axis, 3D axis coming straight out of the screen. So it's sitting on 0, it's sitting on the floor, which is defined as 0. That's fine. The frame needs to be sitting on top of the sheet. So we know that the sheet is 4 millimeters. So if I change the bottom of the frame to 4, it'll start at 4 millimeters and come towards me, if that makes sense, sitting on the sheet. And the last thing, if I go back to the plates should be sitting on the frame, which is 25 millimeters, because we defined that, we extruded it with 25 plus the 4 millimeters of the sheet. So it's got a sheet, then the frame, and the plate sit on top of that. You could probably work at 25 plus 4, but if you can't, you can just type it in the box there, and it'll do 29. So now, when we spin this round, we can see that the plates sit on top of the frame, which sits on top of the sheet. If I can go to a front view, you can see it clearly there. Go to an isometric view, go to the OpenGL render, and there we go. There's a flat there with everything sitting where it's supposed to be.